All right, let's go over the level 3 question for conservation of momentum. So this was question number 8 on velocity of a softball. And it says, assume the ball has a mass of 0.198 kilograms and comes in with an initial velocity from the pitch in problem 1. Okay, so I've already set up the pitch in problem 1 was coming in at 30.5 meters per second, so I've drawn that out in my sketch. The ball leaves with a velocity of the hit from your answer in problem 4. Okay, so my hit in problem 4 was leaving at a speed of 45.5 meters per second, and then it says remember to make this value negative since it's the opposite direction of the pitch. So that makes sense. Since I set the blue direction as positive, the opposite of that would have to be negative, so I'm going to make it negative 45.5. Okay. If the softball player started her hit while standing still, and there was no friction between the softball player and the ground, and the softball player had a mass of 60 kilograms, how fast would the softball player be moving backwards after the hit? So I'm going to start by setting up my data table here. Before the collision, so right here in the middle, that's going to be my hit, right? That's my differentiation from before and after. Before the collision, the ball has a mass of 0.198 kilograms. So 0.198 kilograms. And after the hit, the ball's mass hasn't changed, also 0.198 kilograms. The masses are also going to stay consistent. So the mass of the person is 60 kilograms. So the mass of the person is going to be 60 kilograms before and 60 kilograms after. All right, now for the velocities. The ball, before the collision, it's moving in at 30.5 meters per second. So I'm going to put in 30.5 meters per second. The person, she's hitting a softball pitch, and it says that she starts her hit while standing still. Okay, so since she's starting her hit while standing still, I know that she's going to start with a velocity of 0 meters per second because she's not moving. After the hit, the ball's velocity is going to leave at 45.5, and I have to make sure that's negative, so that's going to be negative 45.5 meters per second. And the question is, how fast would the softball player be moving backwards after the hit? So I'm going to solve for this variable right here, and I'm going to label it v. Okay. All right. So now I can set up my equation, and I'm going to set up my equation using the conservation of momentum equation for two separate objects. So that's going to be m1 v1 plus m2 v2 equals m1 v1 plus m2 v2. And this is going to be before the hit, and this is going to be after the hit. So now I can plug in numbers. Object 1 is going to be the ball. So I'm going to take those values and put them in here. Object 2 is going to be the person. So I can take those values and put them in here. Then after, object 1 is going to be the ball. So I'm going to take those and put them in there. And the person I'm going to put in here. Cool. So let's just input those variables. I'll get mass of 0.198 kilograms times the velocity of 30.5 meters per second plus a mass of 60 kilograms times a velocity of 0 meters per second equals the mass of the ball, 0.198 kilograms, times the speed of the ball, which is negative 45.5 meters per second, plus the mass of the person, 60 kilograms, times the unknown velocity. Okay, so now I can multiply out all my parts. 60 times 0 is going to equal 0. That's the easiest one. Equals, at the end, I'm still going to end up with plus 60v. 0.198 times 45.5. I don't know that number off the top of my head. But now that I have my calculator, I can plug that in and know that it is 6.039 kilograms meters per second. And then on this side, it's going to be 0.198 times 45.5, 9.009. Except that's a negative sign right there, negative 45.5. So I got to make sure that's a negative 9. All right, now to solve, I'm going to add 9.009 to both sides. That'll cancel these guys out. And when I add that, 15.048 kilograms meters per second equals 60v. And then I can solve by dividing by 60. And I get v equals 15 divided by 60, 0.25 meters per second. Because this was 60 kilograms, that's a 60 kilograms. The kilograms and the kilograms are going to cancel, and that leaves me with a unit of meters per second. So my final answer would be the softball player should be moving backwards at 0.25 meters per second. And that seems like a logical answer for a person getting pushed backwards by a pitch, because the ball's much smaller than she is, and it was coming in much faster. So that's perfect. So you will definitely see a question like that for level 3 on the conservation of momentum test.